Good day everyone, I am Frederic Salimi. This e-course will be uploaded in our training workspace. If you are interested in full access of this e-course, please send us an email given in description. Have a good day and talk to you later.
A brief description about my qualification and experience. I have a master's degree in dependability, which covers safety, reliability, maintainability, and availability. I also have a BS degree in process control and instrumentation. I worked several years with engineering companies like Technip and operators like Total. I was involved in pre-project, FEED, detailed design, construction, and operation. Today we discuss about simultaneous operations. This is a generic version and will be customized later. This course takes 1 day. We give you access to EPC 365 training monitor for discussions. The objective of this course is to give a practical understanding of simultaneous operations for oil and gas installations. So here is a typical life cycle model for SIMOPS. So let's first start by definitions of the SIMOP. A SIMOP operation can be defined as a situation where several operations involve more than one responsible parties, contractor, operator, vendor, can occur at the same time in the same area. So for the life cycle model is first we have to identify SIMOPS. Then there will be a kickoff meeting identifying a scope of work. And each party prepares work-specific dossier, SIMOP assessment review, review risk, identify specific mitigation measures, develop hierarchy of the controls, and then develop SIMOP interface documents. For example, propose identified SIMOP procedures and control risk and mitigation, and contingency plan, and also management of change, authorization, permit to work, and communication plan. And then preparation for SIMOP is we have to define clearly the roles and responsibilities and the workplace communication, and carry out SIMOP, and this for the meeting, communication, authorization, permit to work, change control, and then change deviation. If no, is close out. If yes, again the same process. Definitions of the SIMOP. We have one kind of SIMOPS is SIMOPS construction, which is the operational performed or in the vicinity of an oil and gas installation on which the extraction, treatment, injection, storage, or transport of hydrocarbon is carried out, which create major risk entailed by the simultaneity of these activities. The SIMOP may include, depending on the associated risk, the operations required for the placing and withdrawal of heavy equipment for such work. And then SIMOPS drilling means the heavy operation performed by drilling a workover rig on a well, which is one of the number of clustered surface or subsea wells on which the extraction or injection of hydrocarbon is carried out. The SIMOP may include, depending on the associated risk, the operation required for the placing and withdrawal of heavy equipment of such operations. A schedule is we have to look at long-term project goals. For example, here about the drilling operation, and construction groups. We have to know the planning and the SIMOP, possible SIMOP number. For example, here there were 2 and also 8. So we have also to define the responsibilities. For example, the general manager is responsible for deciding to carry out SIMOP drilling and production either during development of an oil and gas field or for workover operations. He's also responsible for appointing a specific responsible for safety and environment on site, RSES, for the installation under SIMOP and defining whom he is accountable to and the boundaries of the areas under his responsibility. Operation manager, normally for offshore, is authorization to proceed with the moving or installation of the rig on the cluster is given by the operation manager on the basis of the rig contract, SIMOP general safety dossier, rig approach, and installation procedure. The same thing for the operation manager for offshore, rig installation procedure, etc. Startup of the well operation and withdrawal of the rig. So these are the responsibilities should be clearly defined for the SIMOP dossier. So I would like to go through the responsibility for the safety and environment coordinator on site, RSES. RSES is the only person to have the leadership and responsibility over the activities when simultaneous operations are carried. The RSES is responsible for safety and environment within SIMOPS area, in the area, and RSES is also entitled authority to release the permit to work. And the RSES has the leadership and is responsible for activity, more particularly for the compliance with the rules, regulation, risk control policies and procedures, the follow-up of working conditions of the safety system, defining the priorities and deciding the simultaneous activities, approving new well startup and well reopening, ensuring the proper coordination and the safe management of the simultaneous activities, deciding further risk control measure as required by the situation, and managing a rescue operation in the event of an accident. And RSES is permanently present on the site. Very important. So this is a typical SIMOP specific checks and tests. For example, here, for example, prior to start a SIMOP, for example, pressure check, CSSV, Christmas tree valves, and during the SIMOP is pressure check. So these are the things about fire and gas detection, flow in the low pressure. All of these things should be in the SIMOP dossier. SIMOP hazard identification. So we have to select source of hazard, for example, activity, material, tools, equipment dealing related to activity, crane, forklift, etc. Identifying location related to activity, height, depth, confined space. Installation close proximity to activity, vessel containing hydrocarbon, life facility, emergency exit, etc. Will the activity needs access control affect other personnel in the vicinity? Which material are used and in what quantities? Chemical, combustible. And also add a new hazard if it is not in the hazard register. Identify the hazard inherent to the activities or task. Identify the potential of hazard and consequence induced on personnel, environment, and asset. Identify probability linked to each identified hazard, and identify severity linked to each identified hazards, and identify the risk linked to each identified hazards. So this is the probability, and this is the severity, and this is criticality matrix. We make it a very easy to do, and this is the high risk, and this is has to be done a risk assessment for the SIMOP areas. We have a couple of here SIMOP guide words, and I wrote it here at the end of this e-course. We give 2 examples of tie-in that simultaneous for the tie-in installation. Mitigation process is normally substitution of dangerous material, tools, and equipment, isolation and deviation or reduction of adverse effect, reduction in the number of persons exposed, reduction of exposure period, instruction of personnel, protection of personnel, and protection of asset and equipment. These are mitigation process. So the task, determine if all tasks of the job are needed, decide whether the critical task can be performed in a different manner, review whether amended timing will be safer, decide how the job can be done safer. About the people involved, what are the needs for the rules, job instruction and training, what are the needs for a specific supervision, and are other people at risk and protection needed. The tools and equipment, what are the potential hazards, can hazard potential be reduced? And the working environment, is there a threat by adverse weather conditions? Is good housekeeping possible during the job? Is the job conflicting with other jobs? This is important. Are people restricted in escape possibilities? And once the risks are assessed and depending on their level, it is crucial to determine mitigation measures, which could be administration control, internal project procedures, permit to work, toolbox. At the end of this e-course, I give you an example of a toolbox, safety talk, checklist, specific measures, technical measures, design change, and I will show you later how we did the design change for a cluster, modification, preventive maintenance, check, additional measures, work procedures, and personal measures, for example, accreditation, training, PPE, and residual risk evaluation. Once the mitigation measures are agreed, each hazard is re-evaluated using the same method and the residual risk level calculated. A risk assessment should be done until allowed residual risk is achieved. So I will show you a typical SIMOP cases for a project onshore. In fact, the tying of the gas export pipeline on the company pipeline, and it was for the interface parties is construction and operation, and tying in confirmed production well, other SIMOPs at cluster, and operation and conversion of producer well into the CO2 injection wells, construction operation, and deferred installation of CO2 compression, transport and injection to the of the CO2. and construction of main road at company pipeline crossing. I will explain this too, how it was. So at the beginning, this is in cluster, and then the installations of the all pipe element and flow line for the cylinder injection system, including the vent. The vent is deferred, so this too is deferred for later stage. And the only piping element installed at cluster for injection flow line at CPS startup is the connection to the production manifold here, which will be used when the well will be converted to CO2 injection well. This shall be blinded at CPF startup and illustrated in green here. So the only pipe here was this one. And then the part to install for the deferred installation of the CO2 injection line is highlighted in red. At the beginning it was here, but because of the SIMOP risk assessment, they decided to move it here for future, and it comes here for the construction activities be in a safer situation. This is a construction of the road at pipeline crossing. So the SIMOP area is this area, and the main road is crossing and routed over the 48-inch pipeline. At the construction of the main road to facility will start after installation and start of the pipeline. So a SIMOP is therefore identified. So in order to mitigate the risk associated with the construction, excavation and lifting works for this crossing over a live 40-inch buried pipeline, it was recommended to select a bridge design for this crossing rather than the typical design. The road would pass over the pipeline on a concrete bridge that could possibly be prefabricated. So here this was done in the design for reducing the SIMOP risk. So now I show you how you can go for EPC 365 training workspace. You click on SIMOP here, Simultaneous Operation Training, and then click on SIMOP Training here. When you are here, you can here add all the documents related to company. Then we will create a customized training for your project or for your installation. You can also write the SIMOP issues that you have, and all this e-course will be for your approval. And when it will be approved, we put it in the training workspace, and the trainee can ask a question, and then we will answer to their question. For example, here it is written, when should we perform SIMOP? SIMOP, you can do it in the feed, and you take into consideration, as I said, for example, you put in the cluster to incoming flow line far from the existing installation for future. I added a simultaneous operation toolbox talk, and it is at BP Angola FPSO, which shows explanation for this for the workers, how they have what they have to understand what is the simultaneous operation. Thank you for your attention. If you have any question about this e-course, please send us an email to pmc@epc365.com. We have two websites. One is in French, the other one in English. There are request form there, so you can send us an email. As soon as we have your email, we get back to you as soon as possible. Have a good day and talk to you in our next workshop.
Simultaneous operations. You shorten that to SIMOPS. That's what we're talking about, which is 2 or more activities at the same time, place. I want you to think about where that happens in your life. Not just on here. Think about when you're at home. Think about your kitchen at home. Think about your wife is cooking your dinner. You're going in the kitchen at the same time to make some coffee. You have a baby in the kitchen that your wife is trying to feed while she's cooking the dinner. Your older children are coming in to the refrigerator for some drink and some fruit at the same time as your wife is cooking the dinner, feeding the baby, and you're making the coffee. And then finally, your grandmother comes in, she's lost her glasses, she doesn't know where things are, she wants the TV controller. All of these things happen in one location. Many people working that location, doing different things. This is kind of SIMOPS at your home. You have SIMOPS on the PSVM. The idea is to avoid harm to people, no harm to property, as in property damage, and no harm to the process. Our prevention method at PSVM is different to your prevention method at home. Your prevention method at home is your experience, and you've been taught by your parents how to survive. At PSVM, your parents start with Mr. SC Fu, and he rolls that down to you at the VSCC meeting. At site, we control the access to our kitchen, okay, by the AA, and who is the area authority, and the PA, the performing authority, against the permit to work system. We do want you to report any conditions that are wrong in your workplace. Same as your kitchen. You see something wrong in your kitchen, you're going to stop it. You're going to say, kids, get out. Grandma, go sit down. Right, let me sort this out so it's a safe place to work. And we respect barricades. In our permits, in our FPSO kitchen, we put barricades up to stop those extra people coming into that workspace.